Hello, my name is also Doliner and I'll be presenting the experiments for lab number 4. So we begin with figure 4.1, where we have the XOR gate connected over here. So over here we have both switches 0 and 1 connected to pins 1 and 2 here on the red and white cables. Pin number 3 coming out of the XOR gate is then going to the LED. Everything's power and grounded here by the sides, top and bottom. And now let's test it out. So when we have one on each side, so either on the first switch or the second switch, we get a 1. And when we turn both on, it turns off. Now we proceed with figure 4.2. Over here we have that same circuit as before, it's just that we have this clock connected to input B. As we see, if we turn the switch on whenever the light is on, we'll see that it gets reversed. So let's try it out right now. So I don't know if it's that easy to see, but the signal from the clock is being reversed once I turn on the switch. So yeah, now we begin with part 2 with the exclusive NOR gate. Over here we can see our inputs A and B. Here on the white and red cables going to the XOR gate. Now the output on pin 3 is then going to pin 4 as an input for the next XOR gate. Now this is going to the BCC power as an input. So this is constantly a 1. And then afterwards we have everything coming to this LED. So if we want to test this out, we see that when we get 2 zeros here by the inputs, we get a high on the LED. When we turn either on by itself, we get a 0, and when we turn both high, we get a 1. Now we continue with part 2. As we see here, we have the same circuit as before, just that we have a clock signal instead of a switch. And as a probe, I just put the clock signal here to this LED. So everything is wired up exactly the same. So we have this going to this LED over here. And now if we test it out, we will see that when it's low, the signal gets inverted, as you can see over here. And when we put it on, it just becomes the same. Now we begin with the bit comparator. As we see over here, we have an XOR gate here on the left and an AND gate on the right. We have 4 inputs, which are A1, A2, B1, and B2. As we see here, 1 bit by itself, in this case A2 and B2 are connected at the same time, or at the same gate, I mean. And then we have A1 and B1 connected to the same gate and being compared. As we see, this output from this gate is then coming and being passed through to the next one. This is power up, or basically putting a 1 to this input and then passing over here. This is making the function of one XNOR gate basically. And then the same thing here on the top, where we have our 2 bits discussed earlier, then being passed to the next gate. We have a 1 over here, and then we have the output coming to the other terminal of the AND gate. The output is then being displayed here by the LED. If we want to test it out, we can see that it's gonna tell us if these 2 bits, or pair of 2 bits, are the same. So we obviously get a low because this is not the same as this, but if we turn this on, we see that it turns on again. So if we test out multiple combinations, we will see that still, if we put both 0, we get a 0 obviously. Turn this one and turn this one, we get the same thing. Turn both this on. 1 1 is not the same as 0 1, so that's good. We get a 0 here. We get 2 1s, it's not equal to 2 zeros. Now we try out, let's say, a different one. Oops, this fell out. Now let's try everything on. We see that it turns on again. And that's it.